Hello guys, today we are going to present you about the project title called as emotional detection. We are trying to do emotional detection using bidirectional LSTM. What is this? We'll go through it. Beyond simple sentiment, emotion detection identifies a spectrum of human feelings moving past positive, negative sentiment analysis to uncover nuanced emotional states. What we are trying to do here is move forward from the primitive positive negative sentiment analysis, that is if a film is a good one or it is a bad review. We want to move forward from this to analyze the sentiment based on like whether the author is joyful or stressed or is surprised while writing this sentence. So based on that we are trying to do this. And next part is broad application. This technology is invaluable for analyzing charts, customer reviews, social media interactions, qualitative feedback, providing deeper insights. We are trying to do all this using bidirectional long short-term memory networks, that is bidirectional LSTM. Next one, what is an emotional detection? Emotion detection is a sophisticated natural language processing task focused on identifying the emotional tone expressed within the text. These are all the categories of human feelings. First one is joy, anger, sadness, fear, surprise, and disgust. How emotion works, detection works. Emotional detection algorithm basically analyzes both individual words as well as the surrounding words to understand the underlying feelings. This contextual analysis is critical for distinguishing between similar words used in different emotional contexts. The system doesn't just look for keywords, it interprets the subtle cues, tones, and sentiment structures that contribute to emotional expressions. Okay, thank you guys. The next part will be taken forward by my teammates.
Hello everyone. Our project is emotion detection using bidirectional LSTM. So for the dataset, we have chosen diarrhea emotion from Hugging Face. So here are there some examples of the training set of the Hugging Face model, which is called a diarrhea emotion. So first of all, this is the code. So first of all, we loaded the data set using the data loader library, and because the diarrhea data set is already inbuilt in this function, load emotion data set. So first of all, we load and preprocess the data set, then we saved the class names, and we are importing this from this JSON file, which are the classes are basically the emotions. So first is anger, fear, joy, love, sadness, and surprise. And after that we tokenize it and padded these sequences. So basically tokenization means splitting the sentence into different parts. Then we build the LSTM model. So this we're all importing this from different files because we have made our code modular. So this by LSTM model is saved in this models folder, as you can see in the by lstm.py. So it is initialized using TensorFlow library. We imported the sequential model because the LSTM is a sequential model from the TensorFlow library, and it has this properties that that the LSTM models have is there's embedding if it is bidirectional or not, then the model itself LSTM, then dense dropout and global max pooling we are using. So after that, going back to the main file, after building the model, then we are training the model on the dataset that we have using we have to split it as we have already split this training set into X train, Y train, and Y xval and YVal respectively. Then we are evaluating the model. After that, so this is the demo, inference demo, if we can use it, but we are going to use our custom sentence in the end. So yes, for that Tufir will explain like how. Here he will give an example to try. Yes, this is an fast API interface is inbuilt using fast API. So here we just have to enter a sentence and it will present the output.
Hello everyone. So now we are going to test this application by entering some text. So here we have a text that is saying that I am feeling really happy today. So we are expecting the model to predict what is the class of this text. Now using the fast API docs
Endpoint.
feature endpoint, we will execute this and we will have a result here. Let's see the result. So the response says as emotion, predicted emotion is joy. If you see that sentence, I am feeling really happy today. The first is predicted emotion, that is joy, which is correct. Now it calculates the probabilities of each classes. What is the probability of each classes in this? First class we had anger. The probability is 0.099. So in these all classes, which are 1, which are probably 5, the highest probability joy has the highest probability. So out of these 5 classes, the class which has the highest probability will be the predicted emotion.
So we can test another sentence if we wish to. So here we can pass some other thing, like I am feeling sad. So execute here. So here it is predicting the predicted emotion is sadness, and it gives us the probabilities as well. There is 98. So yes, that's all. Thank you.
Thank you very much.
Hello everyone, I will explain the conclusion part of our project. We developed a automatic emotion classification from our text and utilized long-term and short-term memory sequence modeling with optional attention and mechanism, and we effectively capture lexical cues and long-range contextual information. Thank you.